When students are first learning their operations, addition, subtraction, multiplication, division, it's often helpful to use models in order to represent these operations so that students can get a mental image and can really physically work with the models and understand them more deeply. So here we're looking at multiplication, and the model we will be considering is the rectangular area model of multiplication. One approach that we can take to this is to use squares and to build a rectangle that is 2 by 3. So this is going to have a height of 2 and a width of 3. And then in order for the student to come up with the answer, they will count the rectangles. They don't necessarily already know the fact that 2 times 3 is equal to 6, but they can count the squares that are there. 1, 2, 3, 4, 5, 6. And this rectangular area model supports the fact that 2 times 3 is equal to 6. We'll go with a slightly larger example and use 3 times 5. So here we will create a rectangle with a height of 3 and a width of 5. Get all my pieces in here. So it's 3 tall and it's going to be 5 wide. And I'll push that together as a rectangle. You will also learn about an array method, and this is similar to that, but there are important differences. One difference is that this is truly a rectangle and it is continuous. We're not thinking of this as separate pieces, but we're thinking of it as a rectangle. So we now have something that is 3 by 5, which is representing 3 times 5, and the student can count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 times 5 is equal to 15, which is the area of this rectangle. We could also do this representation using graph paper. So instead of using physical objects, we could draw this out. So 2 times 3 is going to be a rectangle with a height of 2 and a width of 3. And here as well, I can count up the area. I can count the units, the square units that are inside there. 1, 2, 3, 4, 5, 6. That supports the fact that 2 times 3 is equal to 6. We will do that also with 3 times 5. So here comes our rectangle. 1, 2, 3. 1, 2, 3, 4, 5. We'll finish that off. And again, the student can now count the number of square units in this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are many different models for representing multiplication. We have a repeated addition model, we have an array model, there is a tree model of multiplication and a Cartesian product model of multiplication. There are many different ways that we can help students to understand multiplication. But I particularly like the rectangular area model. And the reason for that is because it's a very flexible model. So it can go along with a student. If a student learns this model when they're young and just starting out, they can use it to apply to other situations later, such as working with larger numbers, working with algebra, working with polynomials in algebra, and also working with multiplication of fractions as well. We're going to take a quick look at how that would happen. So starting first with larger numbers, if a student is asked to multiply 123 by 32, one approach to that is to create a rectangle where we've got 123 represented by 100 plus 20 plus 3. and multiplying that by 32, which we're going to represent by 30 plus 2, which is 32. We'll cut this up into separate areas. Now this is a little more abstract because you don't have like the same sized space representing one number or the number 1. So here we're going to have 3 times 2, which is 6, 3 times 30, which is 90, 20 times 30, so we get 600, 20 times 2, which is 40, 30 times 100, that's the same as 3 times 1, which is 3, followed by those 1, 2, 3 zeros. So we get 3,000, and then 2 times 100, which is 200. In order to get the answer here, you would need to add up all of the pieces. You would have to add up, in some sense, all of the sub-products that you got. And the result here, if you add up all of the numbers in that rectangle, is 3,936. So moving on towards an algebra example, we can set this up similarly. X plus 4 times x plus 5. Well, okay. X plus 4 times x plus 5. We're going to use a rectangular model here as well. So we have 4 times 5, which is 20. 4 times x, which is 4x. 5 times x, which is 5x. And x times x, which is x squared. Here too, you would add up all the pieces. We have an x squared. These are like terms, so 5 plus 4 is 9, we get 9x, and then plus 20. There are many different ways to multiply polynomials. Some people find that they really like this method, and the thing is, if they've learned the rectangular area model from the ground up, then this is going to make a lot of sense to them, especially to begin with. It might make more sense than how it's normally taught, using what we call FOIL, first, outer, inner, last. So if the student knows the rectangular area model, you might start with this and then build to another model later. Or some students just like to stay with this particular model. So the last example we'll do involves fractions. I'm going to do this quickly. It might be a little hard to understand, but I'll put a link to a video that totally explores this. I'll put that in the description below. So we want to do 3/4 times 1/2. And we could draw this, but I have some fraction overlays and they are really convenient to use. So what we have here is a square that represents 1 unit, but then the fraction that's represented here is 3/4 because the unit has been cut into 4 equal pieces. 3 of them are shaded. We have 3 out of 4, or 3/4. I have another fraction here, and that represents a half, and I hope you can see this. The unit, which is our square, has been cut in half. It's been cut into 2 pieces, and one of those has been shaded, so we're indicating that we have 1 out of 2, or 1/2. And what we do is we create one single rectangle, in this case a special kind of rectangle known as a square, and we lay one over the other, so one is horizontal and one is vertical. It is the case that 3/4 times 1/2 is 3/8. Our rule for multiplying fractions is top times top, bottom times bottom. And so let's see here if that matches. How many pieces is the square cut into? 1, 2, 3, 4, 5, 6, 7, 8. And that's our denominator. And how many of those pieces are we concerned with? And that's going to be the number of pieces which are double shaded, and that is 1, 2, 3. And that's the 3 in our numerator. So we have 3 out of 8, or 3/8.